So now let us move to the exercise 1A from the same chapter. Okay, here we go with. Moving to the worksheet 1A of kinematics. First question, a cyclist moves from a certain point X and completes one revolution around a circular path of radius R. So what is given? So there is a cyclist who covers a path length. So here is a cyclist. So on his bicycle, a cyclist moves from a certain point X. Let us name this point as some X. Completes one revolution around a circular path of radius R. Radius was given as R. The distance travelled and the magnitude of displacement. What is distance, children? The distance travelled is nothing but the total path length he covered. So what he is doing? He completes one revolution. So one complete circle he was travelling. So this must be the total path length covered by the person. So this total circumference you need to know. So what is the total value of the circumference? For a circle, the value of the circumference is given by circumference of a circle is 2 pi r. Circumference of a circle is given by 2 pi r. If r is a radius. What else was asked? And magnitude of the displacement. So displacement magnitude means, so from here to here, he started his journey here and again initial position is this x. Even after completing one revolution, he comes back to the same position x. So both initial as well as final position remains same. Then what must be the displacement? Displacement of the body is 0. So how much is the displacement? Displacement of the person is found to be 0. Got it, children? Well, therefore, the distance travelled by the body is 2 pi r. This is the distance. And displacement covered by the body is 0. So 2 pi r comma 0 must be the answer. Hence, the third option is true. Moving ahead with the next question, second one, in the above problem. So that means the next question is also related to the same problem. Person revolving in a circle. The cyclist reaches exactly the other side of the point X. So here is the circle. The person has begun his journey at position X. Exactly after traveling like this, reaches exactly the opposite position. That's it. In the above problem of the cyclist reaches exactly the other side of the point X, that is diametrically opposite to point X. So from here to here. Then the distance travelled and the magnitude of displacement of cyclist are respectively. So no doubt, distance travelled by the body is from this position to the opposite position, that is say some X dash. So how much is the distance travelled, children? No doubt the distance covered by the body is from here to here. It's not complete circle, it is half of the circle. That means complete circle means it must be 2 pi r. One complete revolution means 2 pi r. But half of it means 2 pi r by 2. So further simplification gives the result as pi r. So how much is the distance covered by the body? It's only pi r. From here to here it is only pi r. If it happens to be total means it must be 2 pi r. So distance traveled is found to be pi r. And the magnitude of the displacement means this must be your initial position, this must be final position, and here gives your displacement. The value of displacement equals to the line joining the initial position and the final position. Magnitude means from here to here. As we know that the radius of the circle is r, then this gives the total value as diameter. The value of diameter is equals to 2 times of the radius. Hence it must be 2r. Therefore the distance covered by the body is pi r and the displacement of the body is 2r. Therefore, the correct option must be option 1. Next, moving to the third question, children. Third one, considering the above problem, the same problem, that person moving in a circumference of a circle starting from a point X, the cyclist reaches a point Z as shown in the figure. So, this is the figure as shown, and now the cyclist reaches exactly to some position say Z, something like this it was given. Okay, from here to here. So this person now moves from point X to point Z. This is the displacement of the body. Yes, only that particular portion, children. Then the distance travelled and the magnitude of the displacement of the cycle is. Children, earlier we have discussed that if the person covers complete circle means it must be 2 pi r. If the person travels only half of the circle means it must be pi r. Okay, half of that, half of this is 2 pi r by 2, it is pi r. But if the person travels only 1/4. So 1/4, 1/4, 1/4 and 1/4. So now this person travels only quarter circle, 1/4 of the circle. Then the distance travelled must be equals to 1/4 of the total path. Total path is 2 pi r. Now he travels only 1/4 of the portion. So how much is that? 2 goes 2 times and this will be pi r upon 2. So distance covered by the body from here to here is how much, children? It is pi r by 2. So maybe the first option or third option might be true. So we are also asked to find out the magnitude of displacement. So magnitude of displacement, in order to find out the magnitude of displacement, it's nothing but the line joining from initial position to the final position. What is the initial position? Here is your initial position and here must be your final position. The line joining from initial position to the final position is something like this. So this total path length you have to find out, children, from here to here. So how much is that? If you observe the picture carefully, so this forms a right angle triangle. In a right angle triangle, if this length is r, then for here also it must be r. And these are the two sides of the right angle and this is the hypotenuse side. So hypotenuse side is equals to square equals to square of the sum of the other two sides. So displacement can be given as how much, children? Root over, this is equals to root over r square plus r square. How much is that? R square plus r square, and this is given as 2r square under root r root 2. How much is that? R root 2. Hence the third option must be true. Okay. So if he only covers 1/4 of the circle, then the total distance covered by him is 2 pi r upon 4 parts. So by upon 4 it is pi r by 2, and displacement is equals to the line joining the initial and final position. So from the formula for right angle triangle, Pythagoras theorem, applying Pythagoras theorem, hypotenuse square equals to sum of the squares of the other two sides. So you'll get the answer as pi r by 2 comma root 2 r. So moving to the fourth question, a player completes a circular path of radius r. Again the same circular pattern, children. So what was given? A circular path is there. Okay, and for this, the radius is given as r. A player completes a circular path of radius r and time is 40 seconds. How much is that? 40 seconds is the time given. At the end of 2 minutes 20 seconds, displacement will be. So, to complete one circular path, he takes 40 seconds. To complete 2 circular paths, he must take 80 seconds. To complete 3 circular paths, he must take one more 40. That is 120 seconds. But here, how much time was given, children? 2 minutes 20 seconds. So, let us find out how much time does this 2 minutes 20 seconds. 2 minutes 20 seconds means 2 minutes means each minute has 60 seconds. So, 2 times 2 minutes means 2 into 60 and additionally we have 20 seconds. So, this is 120 seconds plus 20 seconds all together it covers 140 seconds. So, the player revolves around the circle in how long, children? For 140 seconds he is in motion. Okay, so let us see what exactly happens. Now, for 140 seconds, where his final position be? For the first 40 seconds, he will start here. Yes. For first 40 seconds, starting here, he moves like this, comes back. 40 seconds over. Next 40 seconds, again one more revolution. Now 80 seconds over. Next 40 seconds, one more revolution. Next, now 120 seconds over. After 120 seconds, how many more seconds you are left with? Only 20. So, for complete revolution, 40 seconds means in 20 seconds, he only covers a half revolution. In 20 seconds, he covers only half revolution. So, after 140 seconds, he finishes 3.5 rounds. How many rounds? 3.5 rounds. In 120 seconds, 3 rounds and next remaining 20 seconds, half round. So, 3.5 rounds. After that, his final position will be here. He started his journey here. He started his journey here and he finished his journey at this position. So, now you are only asked to find the displacement, not the distance. Okay, distance means 3 times 2 pi r plus 1 time pi r, 4. Okay, so that is totally different. Totally 7 pi r you will be getting. But you are only asked to find displacement. So, what is meant by displacement, children? The line joining the initial position and the final position itself is your displacement. Therefore, how to find out displacement? Displacement is equals to initial position to final position. So, from here to here it is only r and again from here to here it is one more r. So, what is the total displacement? R plus r is found to be 2r. So, the correct option must be option 1, that is 2r. Clear? Moving ahead with the next one, that is 5th question. A man walks 8 meters towards east. Where is he going? A man walks 8 meters towards east, 6 meters towards north and his displacement is. This problem can be solved in 2 methods, children. In the method of IJK vectors. Okay, so both methods I'll explain. So, wherever it is comfortable, we'll go with that. This is north, south, east and west. So, what he was given is, man walks 8 meters towards east. Where is the east? This way. How long is he traveling? 8 meters. And 6 meters towards north. How long? Here 6 meters towards, this is north direction, 6 meters, east direction, 8 meters. His displacement is, now you are asked to find out the displacement. This is your initial position, here is your final position. This must be your displacement. So, what is the displacement, children? So, the displacement of this can be given as root over, so right angle triangle, something like if the arrow is extended, it forms a right angle triangle. This vector plus this vector gives the resultant vector. Okay. So that is nothing but 8 square plus 6 square. How much is the 8 square plus 6 square? The value must be 64 plus 36, and this is root 100 is found to be 10 meters. So displacement vector is equals to 10 meters. Only magnitude was 10 meters. What about the direction? Here the direction is in this direction, something like this. Okay. So direction is something cross in between north and east. So this is northeast. Which direction is that? Northeast. So displacement is 10 meters northeast. Therefore, the correct option must be option 1. If you are a bit confused with this model, let us try to solve by something interesting model, children. Always see plot x-axis and y-axis. Along x-axis, represent it with orthogonal unit vector I cap. Along negative x-axis, minus I cap. Here plus j cap, and here it has minus j cap. This is your origin. So a person walks 8 meters towards east. East means here only. East means what vector orthogonal? I cap. So the displacement vector is equals to like this, 8 I cap. Magnitude is 8, direction is given as the unit vector I cap. And next to that, and plus along with that, 6 meters towards north. North means upward direction indicated by j cap. How much magnitude? 6 meters north, j cap. So displacement vector is given as 8 I cap plus 6 j cap. So between these two, the person is been going. These two indicates your northeast direction. Both I cap and j cap means I cap, j cap indicates a positive xy plane. So this plane, in this plane, it indicates your northeast direction. What about the magnitude? Magnitude is nothing but root over coefficient square, 8 square plus 6 square. This is nothing but 64 plus 36 under root is given as root over 100. Hence, the magnitude of the displacement vector is root 100 is given as 10 meters and it lies in the xy plane, positive xy plane. So, positive xy plane indicates the first quadrant, in that first quadrant, northeast direction. So, 10 meters northeast direction. The same answer. So, this must be the proper way of solving the numerical. So, shall we move to the next one, children? Sixth question, similar to the previous one. A man has to go 50 meters due north. So, let us replace the coordinate system once again. Here is your I cap, j cap, minus I cap and minus j cap. So, what was given? A man has to go 50 meter due north. North means upward. So, 50 meter north means j cap. 40 meter due east. East means positive x-axis. So, and 40 meter, which direction? East. East means I cap. And also 20 meter due south. Along with that, 20 meter due south. South means downward direction. So, 20 meter downward, it is indicated as minus j cap. Earlier it was north and east indicated by plus j and minus I, but south is indicated by minus j. So, this is the resultant value. So, what distance he has to walk to reach the field? Total distance, how much? Let us indicate this. Magnitude of the displacement or the total distance he has to ask. Well, first of all, this will be the displacement vector we will be solving. Distance is nothing but the total path length covered. Whether it is whatever be the direction, we are not bothered about the direction. In order to find out the distance covered by the body, distance covered by the body is nothing but the total path length. So what is the path length covered? Initially he moved 50 meters, later he moved 40 meters, and finally he covered 20 meters. So 50 plus 40 plus 20 is 90 plus 20, it is 110 meters. The total path length covered by the body, whatever be the direction, indicates your distance. Hence, the total distance covered by the body is found to be 110 meters. Distance covered by the body is only 110 meters. Now, so first option is done, 110 meters, maybe one among this. You are asked to find out the displacement from his house to the field. So, displacement matters. It depends on direction. Hence, directions are given by j cap, I cap and minus j cap. So, moving to the finding out the displacement vector, S bar is given as, this is j cap and this is minus j cap. So, first of all, let us solve this. 50 j cap plus 40 I cap plus and minus 20 j cap. I cap is this. So, displacement vector is 40 I cap. Okay, first of all, I wrote this, and what are left over? 50j minus 20j. Finally, it is 30j. I and j, the displacement vector is, where is it present? Where is it located? I and j. I and j indicates this plane. So, this indicates your northeast direction. Okay. So, displacement vector is along northeast direction because it belongs to this IJ plane. Coming to the magnitude of the displacement vector, magnitude of the displacement vector is taken as 40 square plus 30 square. How much is the 40 square? It is 1600. Plus 30 square is 900, and finally this is 2500 under root. So what is the value of root over 2500, children? So magnitude of the displacement vector is equals to root 2500 is 50 meters. So 50 meters in northeast direction. So displacement vector is 50 meters northeast, distance is 110 meters. Hence, the only correct option is option 3. Distance is 110 meters and displacement is 50 meters towards northeast. I think it is clear, my children. Well, so now let us move to the next one, that is 7th question. A particle starts from the origin. So where the particle starts from? The particle starts from origin. Goes along the x-axis to the point 20 meter, 0. So let us visualize this. Well, so this must be your origin. Let us plot this as 0, 0. Goes along the x-axis something like 20, 0. Because on y-axis it is 0, x-axis 20. And then returns along the same line minus 20, 0. So, no displacement along y-axis. Only along x-axis it travels. Straight line motion. Find the distance and displacement of the particle during this trip. So, first of all, let us try to find out the distance. What is the total distance traveled? Total distance traveled by the body is from here to here. How much it has covered, children? 0 to 20, it is 20 meters. So, initially it went 20 meters. And again turned back from here to here. How much is that? From if here to here it is 20, here to here also path length is 20 meters. And again from here to here, distance indicates only positive values. Only the magnitude, how much. How much means here to here 20, here to here 20, and again here to here also 20. To indicate minus 20, on how much path length it has covered. It's 20, not minus 20. So again you have, it has covered 20. Okay, 20 meters, again 20 meters back, again 20 meters forward, backward. Therefore, the total distance covered is 20 plus 20 plus 20 is found to be 60 meters. The distance covered by the body during this trip is only 60 meters. You are also asked to find out the displacement part of this particle during this trip. In order to find the displacement of the particle, here you have to consider both negative as well as positive values. Displacement depends on direction. Initially from here to here, along positive x-axis. So, positive x-axis indicated as 20 I cap. Positive x-axis I cap. Again, from here to here directly or break journey. So, directly we'll take, this is your initial position. This again from here to here. The total journey is now backward direction. That means moving along the negative x-axis. Negative x-axis, from here to here it is 20, here to here it is 20. Totally 40 along negative x-axis. Negative x-axis means minus I cap. If not, you take it as 20 minus I cap and again 20. Backward direction. Backward direction means minus I cap. Forward direction means plus I cap. Remember that. So, 20 I cap plus 40 minus I is minus 40 I cap. So, this is also I, that is also I. Finally, you got it as 20 I cap. So, the displacement of this body is found to be minus 20 I cap. So, very clearly, this can also be written as, or I can even write this as 20 times of minus I cap. What does it mean? The magnitude of the displacement vector is 20 meters, whereas it is directed along the negative x-axis. Minus I cap indicates negative I caps. So, what is the displacement? 20 meters along negative x direction, negative direction. So, this must be a displacement vector. So, which one is the correct option? Answer is 60 and 20 along negative. So, only correct option is third one. Distance is 60 and 20 meters in negative direction is your displacement.